So the question we're going to look at today is, say that you have a rectangle that has an area of 20 and your sides are tripled. What happens to the perimeter of that rectangle and what happens to the area of that rectangle? Well, without specifically knowing the sides, we might not necessarily be able to figure that out directly, but what we found out is that there is a relationship between the ratios of what happens to the sides and what happens to the perimeters and what happens to the areas. So let's do a little discovery activity to figure out what goes on. So with figure A, it says figure B has double the dimensions of figure A and figure C has triple the dimensions. So we're going to deal with double, which is times 2, and triple, which is times 3. So my original dimensions in figure A are 2 by 3. So I have a 2 by 3 rectangle. That means that my perimeter is 4 plus 6, which is 10. So my perimeter is 10, and my area is 6. Okay, just base times height. So then now everything is double. So if I double the 2, then the side length is 4, and I double the 3, then my side length is 6. So now the dimensions are 4 by 6. My perimeter is 8 plus 12, so it is 20, and my area is 6 times 4, which is 24. Now, in figure C is tripled figure A. So if I triple 2, 2 times 3 is 6, and 3 times 3 is 9. So now my dimensions are 6 by 9. My perimeter is now 30, 2 times 6 plus 2 times 9, and my area is now 54. So let's look at our scale factor of figure A to figure B. So from figure A to figure B, it would be 2 over 4. Or you could also use 3 over 6, but here's what you find is that those both reduce to 1/2. So figure A is half as big as figure B. Okay, what is the ratio of the perimeters? Well, let's go in the same direction, A over B. So it's because it says figure A to figure B, so I'm going to do A over B. So the perimeter of A over B, well, that would be 10 over 20, which that reduces to 1 over 2. And then the ratio of the areas of A over B would be 24 over 6. Oh, excuse me, other way around. 6 over 24, which reduces to 1/4. So we kind of see maybe a pattern going on there, but let's check and see. So let's do the same thing. Let's do A over C, figure A to figure C. So figure A, we want to do our scale factor. So scale factor means compare your sides. So my sides were 2 over 6 or 3 over 9. Both of those reduce to 1 over 3. So my scale factor is 1/3. Figure A is 1/3 as big as C, or C is 3 times bigger. So the ratio of the perimeters, so we look at our perimeter, 10 over 30, which is 1/3. And then the ratio of our areas is 6 over 54. Which when that reduces, you can reduce that to 6 goes into 6 one time and 6 goes into 54 9 times, so it reduces to 1 over 9. So if you look at those, you notice the pattern. Do you notice that the scale factor and the ratio of the perimeters is always the same? Well, that will always happen. So what that means to you is this, that if the sides double, then the perimeter will also double. Okay, so if my sides are in a ratio of A to B, my perimeters are also going to be in that same ratio A to B. So that means if my sides are 2 times bigger, then my perimeter will also be 2 times bigger. If it's 3 times bigger, then my perimeter will also be 3 times bigger. Same thing, if it's half as big, then my perimeter will be half as big. Okay, now look at the areas. I went from 1/2 to 1/4, and I went from 1/3 to 1/9. Well, what happens is it's area squared. So whatever happens to the sides, if I square it, that is what happens to the area. Now let me kind of take you to, let's do 2/3, right? If I do 2/3, then if my sides are 2/3 as big, then my perimeter will be 2/3 as big. So now let's look at this and what happens to the area. So if my sides are twice as big, then my area will be 2 squared or 4 times as big. If my sides are 3 times bigger, then my area will be 3 squared or 9 times bigger. If it's 1/2, then it will be 1/2 squared, which is 1/4 as big. Or if it's 2/3, then it will be 2/3 squared, which is 4/9. Now, the way that you can remember it is your sides have a unit of feet, inches, centimeters, right? Your perimeter has that same unit of measurement, feet, centimeters, inches. But area is feet squared, meters squared, centimeters squared. So that's your clue as to what you're supposed to do. Now, everything always comes back to the sides ratio. We want to know what our scale factor or our sides ratio is. So your scale factor and your sides ratio, those are the same thing. Okay, so let's look at some questions that have to do this and figure out how to find out new measurements based on what happens to the original. So find the ratios of the perimeters and the areas given each of the figures below. And so we're going to use our sides to determine our scale factor. So my sides ratio are in a ratio of 4:8. That reduces to 1/2. And we always want to reduce it. So my sides ratio is 1/2. Then that means that my perimeter ratio is also going to be 1/2. Whatever happens to the sides, that's what happens to the perimeters. They have the same unit of measurement. What's going to happen to my area? Well, area is unit squared. So you take your sides, you square it. 1 squared is 1, 2 squared is 4. And so my area will be 4 times bigger, or 1/4, the smaller one is 1/4 as big. You do the same thing. If my sides ratio is 9/12, always reduce. So 3 goes into 9 3 times, 3 goes into 12 4 times. So my side ratio is 3:4. My perimeter ratio will be the same, 3:4. And my area ratio will be 9:16. Now, we have the same thing because this is a rectangle, right? We have all of our opposite sides are congruent. So if we compare this, so my sides are in a ratio of 12:5. So that means my perimeter ratio, and that can't be reduced, my perimeter ratio will also be 12:5, and because it's still in feet, right? Sides are feet, perimeter is feet, area is feet squared, so my area ratio will be 144:25. So what this helps us do is we don't have to know all the measurements. We don't have to know what everything else is individually. We can take these and find out what's going to happen to our areas. Later on, we'll look at volumes too. So the area of one figure is given. So the area of my larger pentagon, this one is 100. The question is, what's the area? Now, I don't know what happened to my areas yet, but I can look at what happens to my sides and use that to figure out what happens to the areas. So look at this. My sides ratio is 30:10. It doesn't matter if you do 30/10 or 10/30. But once you set it up, you want to be consistent because we're going to use a proportion to set this up. Okay, but we can't compare, here's the deal. We can't compare sides over sides equals area over area. You can't do that. You have to compare area with area, sides with sides, perimeter with perimeter. Okay, so we want to do this and we want to reduce it. So that means my side ratio is 3/1. My large side and my small side. Now, here's what you got to do. You have to convert that side ratio to an area ratio. Well, sides ratio, perimeter ratio would be 3:1, and my area ratio would be 3/1 squared, right? That's my area ratio. That gives me 9:1. So my large one would have an area that is 9 times bigger than my small one. Well, I gave you the area of the large one, so we're going to put that on top, and the area of my small one is going to go on bottom. Okay, so it doesn't matter, large over small, small over large, just once you decide. But you have to compare the area ratio to the areas. So you have to convert it, okay? So once you do that, you have to convert sides to areas, your side ratios to your area ratios. Then you cross multiply. So we have 100 is equal to 9x, which means that my small area is 11. Find the area of the other figure to the nearest whole number. So it's 11.1 or 11 centimeters. So the area of my small one is 11. And I check, it is smaller, so I did everything in the right proportion as far as using large over small. Okay, so let's do the second one, the area of the larger rhombus. So I have the larger rhombus is 500. The question is, what's the smaller one? Okay, again, I have the side ratios, so I set it up. My side ratio is 10/25. Always reduce so you can deal with numbers in their smallest format. So that reduces to 2/5. So my side ratio is 2/5. My area ratio is going to be my sides ratio squared because area is squares. Look, you got squares all over the place here. Okay, so you're going to use that square to remind you to convert it. So my ratio to use to compare my areas is my area ratio, so it's 4/25. So 4 is the area of the small one, 25 is the area of the big one. That's my ratio. So what would be the area of the small one if the area of the big shape is 500? So we do 500 times 4, and then we divide that by 25, and we get that the area of the smaller rhombus is 80 meters squared. Okay, so you have to be comparing the right ratios with the right ratios. You can't compare apples and oranges. Apples with apples, oranges with oranges, inches squared with inches squared, not inches with inches squared. You can't compare that, so you have to convert, okay? So find the scale factor, the ratio of the perimeters for each pair. Now, look at what you're given. You're given areas. So when we compare those, we're going to get our area ratio. Okay, so that's the only thing we can compare is our area ratio. So let's set that up. We get 50/162. Always reduce. So when I reduce, it reduces by 2, and that reduces to 25/81. Now that reduces a little bit. That's nice, right? Because you can see them. So that's inches squared and inches squared. Now, I want to find perimeters. So let's go back to our sides ratio, which is going to be the same as our area ratio. Now remember, it was area squared. So if I come over here and I take the square root, right? I squared it to get the area ratio, so I have to unsquare or square root it to get the sides ratio. So now my side and perimeter ratio will be 5/9. That's both the sides and perimeter. They both have the same ratio because they're both inches. Just they're measured in inches or linear measurements. So the scale factor would be 5/9, and the ratio of the perimeters would be 5/9. So that is my answer. And if you knew what one of the perimeters was, I could find the perimeter of the other one. So two rectangles have areas. So I have area, so I'm going to reduce. I've got 8/98, so we set that up. 8/98, we always reduce it if we can. 2 goes into 8 4 times, and 2 goes into 98 49 times. This is an area ratio, right? It's meters squared and meters squared. I want the perimeter or the side ratio, so I'm going to take the square root, which gives me 2 meters for every 7 meters. So my scale factor is 2/7, and the ratio of the perimeters would be 2/7. So let's look at number 8. The area of a regular octagon is 120 feet squared. What is the regular of a regular octagon that has with sides 1/4 the length of the sides of the larger one? So this is my large, and then I used 1/4, so it's 1/4 as big to get my small. So my sides ratio, my sides were multiplied by 1/4. If my sides are multiplied by 1/4, then my area will be multiplied by 1/4 squared, right? Because we got to convert that. I know what happened to my sides. I want to know what happened to my areas. Because it says, what is the area? Well, to do area, I got to convert it into area. So it's going to be 1/16 as big. Okay, so I have my small area to my large area equals, the large area was 120, so I want to know my small area to my large area. I know it's small over large because 1 is smaller than 16. So I know 1 is the small and 16 is the large. Cross multiply that, you get 120 divided by 16. And you get that the small area is 7.5. Double check, make sure it is indeed smaller than what I originally started with. Now, say, for instance, say that, notice that I don't even care that it's an octagon. It doesn't even matter. I didn't even look at the shape. So let's just say, for instance, you get stuck. So let's say we have a rectangle, and it has an area of 120. Well, I can make up some numbers. 10 times 12 is 120. So now my sides are 1/4 as big. Okay, so 1/4 is big. 10, 1/4 of 10. So if you take 10 and you divide it by 4, then you get 1/4 as big would be 2.5. And 1/4 of 12 would be 3. Well, the area of this is 120, and then 2.5 times 3 is 7.5. So if all else fails and you cannot remember and you can't figure out how to use these ratios, make up some numbers that give you the area or the perimeter that you started with. Do what it says. My sides were 1/4 the length. And then see what happens to your new area or what your new perimeter is. You can actually calculate it, and it really doesn't matter what shape you use. Like, I mean, I did the same math with a rectangle. It doesn't matter what the sides are. You don't even have to pay attention to that. All you need is the scale factor, which gives you the ratio of the perimeters.